Hi there, Anderson AC, and all the rest of you good people out there. I hope that you're all safe and sound and that health is with you in these still difficult times. Um, Regarding kind of a follow up on your um, question in regards to part family and assembly. Creating an assembly thereof. I thought that I would revisit since I have you recorded an AVI with some more meat on the bone, kind of. So I kind of have a better understanding on what you want to do. Um, Now to do what you are after, and especially with the comment earlier where you want a change to reflect in all the downstream parts. Now, obviously, you can do that somewhat with wave linking, and that would probably do the trick. Now, I do not quite know the complexity of your parts, but seems fairly straightforward, and I do believe that you can kind of solve that with part family. Now you have to work according to kind of be a bit structured when handling this, and you would need a not necessarily, but I would, since you want to be able to control it through one spreadsheet, I recommend using an external spreadsheet, because that's where you would collect all the information in regards to the kind of systems design of the whole assembly, so to say. So in order to do that, I kind of wanted to, in a very simplistic way, simulate the kind of parts that you were discussing. So this would kind of um, reflect an electric motor with a stator and a rotor, including the mounting there. And we will kind of use this as a base for the coming discussion and kind of demonstration of this. So I have obviously designed all these parts. Not that advanced really, but still. So we got the complete assembly, and I named it Master. I've got the stator, I named it Master, and I got the rotor, and I named that Master as well. I have some assembly constraints in here. We got a distance in here, and that will be between the kind of back face on this motor and the shaft or axle of the rotor there. So that means that will enable me to vary the position of that axle. So that would be the only expression I would have in the engine assembly. So if we open up the expression editor, we can see that we got an expression here which I call dist, and this is 1 millimeter currently in the master. We got the stator. We have some expressions in here as well. We do not want all. We use the named ones, so we can see that those are the three that I want to be able to control through the spreadsheet. I got the stator axle seating. That will be the diameter. I should have written that as well. We have, and that is based on the actual axis diameter. So this would be a clearance to that axis. A set clearance, I should say. We have a stator length and we have a stator outer diameter, and those are controlling the size of this motor, just to give it some expressions that we can control. And we also have the rotor, where it's not that difficult, really. It's really simple. We have an axle diameter and an axle length. That's all we want to control here. We don't want to add too many expressions here for the demo purposes. Okay, so we need to create a bunch of standard parts around this, and since this is an assembly, we need to work bottom up, meaning we will create the rotor and we create the stator first, and we will create their part families as well. So let's make the stator either the work part or the displayed part. In this case, I make it the displayed part. We start the part families, and we see that we have a bunch of parameters that we want to control. We want the stator axle seating, we said, length and outer diameter. We add them to the mix, and we say, well, we can create that. I thought I had set that. Okay, so I will have to set the library every time here. You can do that in the standard otherwise. So I want that in here, and engine part family. That's where we want to save them. Remember that. And then we kick off a spreadsheet. Now this spreadsheet will be the internal spreadsheet in the part family, and I need to connect this to the external spreadsheet. So here we got the stuff that I want to control, and the top line or first line here, that will be the default one. So if nothing else stated here, this will be referring to all the parts in here which is called or have a suffix master after them. We need to connect or hook this up to my external spreadsheet, which I have prepared. So I will open that, and that should be the engine master here with my all the parameters that I want to be able to vary. Firstly, we need the name. So this would be the stator, and that means I need these guys. And this master spreadsheet here, now I made it easy on myself, because each line here will be one configuration. I believe that's the way you want it, but basically you can configure them any way you like once we get to the assembly creation of these part families. Okay, so but now we're focusing on the stator part here. We simply copy them, and we're going to paste them in our part family spreadsheet in this part. And if I simply paste them and say that I want to create a link here, it will be the linked value coming from the original. We want both the OS name and the DB part name to be the same, so I'm going to do this twice in these columns, because I might want to import this into a database or whatever, and the OS part name might be the name, it might be a number. It depends on how you have your system set up. Now, we also have the stator axle seating, the stator length, and the stator outer diameter. I'm going to copy the text up there, because I'm going to link this kind of twice. Once inter spreadsheet kind of, so from this spreadsheet to this spreadsheet, and once from cell to cell, and that is kind of the secret behind all this. So we know that, let's have a look at that. We need a stator axle seating. Now that would be the diameter, maybe a bad expression, but that would be the axle diameter here actually. So I will pick that from the axle, and I will simply copy that column, and I will put it in the stator axle seating column. I will paste that there. Make sure to paste it as a link. Now, looking at that guy there, we can see that that is linking back to the master spreadsheet, and that is kind of key here. We're going to do that with the length as well. We got the stator length, so that comes from the stator column, and we simply copy that. We paste that up here as well. We make sure to paste it as a link, and we're going to do the last one here, as well, the stator outer diameter, and we paste that up here as well. Ensure that it is a link. Thing here is that you got the kind of expression in this cell, a formula coming in here. Now I want to take the value from that formula and link that to the cell over here. So simply I say that equals, that equals the G3 cell. Either you type it or you double click in the G3 cell, and we confirm by enter. If I mark that now and if I expand that, we will have the link to the same column over here. I'm going to do the same here, equals age 3. And same thing here, and we drag and we create the link internal the spreadsheet here now. This would be to the external. And for the stator outer diameter as well, we say I3 there, and confirm by enter, and we expand that guy there. So here we have the setup for our part family. Everything is done. Now we need to confirm and save that part family. So we transfer this data into the actual part here, the master part, and we will populate the part family kind of spreadsheet here. So everything is populated. I can validate this. I'm not going to validate. I'm going to trust that I did it right, and I'm simply just going to create the part within this library here. Now I would set that as standard. I haven't done that. I will have to do that every time here now, but that's not a biggie. So parts are created. Great. That was the first one. We'll make sure to save that. We go back to the engine assembly, and we're going to do that to the rotor as well. Let's open up that in a separate window just to be consistent. We do the part family here as well, and we know that we want to have the possibility to create standardized parts with the following parameters: the axle diameter and the length. We add them to the spreadsheet. We make sure that the path to the parts is the same as previous engine. Should be standardized, of course, and set in the customer defaults, but I haven't got around to do that. So we create the spreadsheet, and we do that. You could, of course, create it up here internally, and that would be really quick as well. But since I'm linking from one spreadsheet to another, I need the spreadsheets open. So from within here, I will open the one I want to link to, because I want to utilize the two here. Same here. We copy the two kind of columns up here, the names of them, and let's put them over here. A good thing might be to put maybe a linked in here as well, just to indicate that these are linked. And we do the same as before. So we say that we want the axle diameter. We want this column in this column, and we say paste, and we say we want that as linked information, meaning if I change here, it will change here. And we do the same for the axle length, and we paste that over here. Also, make sure it's a link. So we're pretty good off there, but we have the axle diameter, and we need to link that internal the spreadsheet. So G3, and enter to that, confirm, and I don't have to repeat that. I can just mark that and make the rectangle bigger there, and it will recognize all those values there in that column. We do the same for the axle length, so that would be H3, and confirm, and we take that little rectangle and expand it. So there we got the links set up to the kind of master spreadsheet here. We also need the names here, and we need the rotor. As these are names, they don't have to be interlinked, because it will just be the name string here. So we paste that there, but they still need to be linked. If I change in the master, I want them to be changed there as well. Cannot paste data. Oops. Let's undo that, and let's paste that, and let's do it as a link. There we go. And let's do that as again. We paste it as a link. So now everything is set up in the spreadsheet. Now we need to populate the part family, and we do that by using the add-ins and save. So now we will have a populated part family kind of internal spreadsheet here in NX, and I can now choose to create these part files. So there we go. We run off and let the system create them. Okay, system have created the part files. We can shut that down, and we okay that, and just for the heck of it, we're gonna save the master, of course. We go back to the assembly, and now it's time to kind of create the configuration from all this parts that we have, and that means we're going to create a part family of the assembly here, and we need that distance value, so we will add that, but we also need the components, because we need to determine what components to be used. We need to set the library again, as I haven't done that in the standards here. And there we are. I thought, there we are. We are going to do this via the spreadsheet. And from there we will open up the master spreadsheet as well. Here we go. So we open up the engine master, because here we have determined what names and what goes with what. Here it's not that difficult really. We have the assembly column here with all the names, and they are fairly simple. We're gonna just simply paste them, ensure that they are links. We do the same in the OS part name column. We do them as links. We have the value, dist value over here. We know that when it comes to the numbers, they become formulas, and formulas are difficult, so we need to do a interpart link column here, so to say. So we're going to copy this guy, and the interpart or inter spreadsheet will be placed here. Make sure it's a link. And then we're going to make sure that this guy is G3. There we go. And yes. And we make sure that this is expanded to all those. And we're going to put the names in here. So that means that since I matched every column here, I can do the stator column here. 1, 2, 3, simple. And we put the stator over here, and we do them as links. And we have the rotor column over here. We do them as links as well. There we go. And everything is set. So the add-ins and part family, and save the part family. And we will populate the internal spreadsheet for part families here. Now all these guys also needs to be created as well. So we run off and create those guys. Everything is successful. Thank you. Okay. And to verify, well, let's open those guys up. We start with the first one. That should be actually the same as what I have. Or maybe not. It depends on how the first one was actually bigger. Yeah, that's right. The second one is probably, well, I don't remember what values I used. But you can see, well, this configuration is completely different from this the original master one. Take the second one as well. That is a smaller version. And we take the final version here. And that's a little bit bigger as well. So, one of the things that you liked here that you wanted to be able to do was to create, for instance, if we go back to the master of, let's say, the stator here, and we say that, well, let's make that the display part. We wanted a couple of holes in here, maybe. Let's see if we can create some holes in here. Let's do the home and let's do a hole. And we're gonna put a hole on top of here. And we're not gonna position it. We're just gonna put it there. Let's say for the heck of it, we need a couple of those. We need one over here. We need the two on the opposite side as well. So we're gonna mirror those faces. I'm gonna mirror that face with, let's say, the mid plane. Not that plane. I need the mid plane, and that would do. And we're gonna do that with. We can use the plane we already have there, or a mid plane. We will have holes all around. Great. So we save that. But the one thing we need to, since this is a master to all the locked versions of the part families here. Obviously, in order to have this reflect down here in all these guys, I need to update the part families here. So we go to Tools, Part Families, we mark all these guys, and we say Update Parts. And there we go. So now we should have, that's the third one. Everything is successful, great. That means if I now look in all these versions, if I look in this one, we can see we have the holes in the corner there, the mounting holes. We have the holes in the corner on the smaller version, and the slightly bigger one has holes as well. And we can see that the positioning of this, the axle is bigger. The diameter of this is bigger. And the position of the rotor is different since it's deeper into the engine here. Okay, so basically that's just what I wanted to convey, and maybe this will get you around your parts, and I hope it will work for you. So with that, I wish all of you good people out there a great day, afternoon, evening, night, morning, wherever you are. Over and out from Fred. Bye for now.